So continuing with the same problem, we got this particular matrix where these are the jobs to be performed in one-to-one format, in one-to-one assignment through different man labeled as 1, 2, 3, 4. So what we did, this was row operation, this is the result of column operation, and now we are on the point of carrying out assignment. So we will identify row with single 0. If that is exhausted, we will go for column. Then we will identify rows with double 0. Then we will go for column, and then we will identify rows and column with one cut and one uncut 0 in the hierarchy, same hierarchy as that of previous one. So now concentrate your mind here how assignment is done. First is, this is first in the order of hierarchy, this is second, and this is third. First in 2 part, row column, second in 2 part, row column, third hierarchy in 2 part, row and column. Suppose if this first row is having, by chance it is having only 1 0. Suppose this first row is having 2 zeros, I will not go for first row. I will search a row with single 0. Now here fortunately we got 0 in first row. So our task is to assign to this 0 in that cell 1C. So how the assignment is done? The process is, you have to mark that 0 with square. Means right now what my assumption is, I have assigned man 1 to job C. Now job C is already assigned right now to man C. So can you again assign this C job to somebody else? Definitely no. Why? Because it is one-to-one assignment, and therefore when you assign single pure 0 of any row and any column, you have to cross off zeros of related columns and rows. If you are assigning 2 rows, cross off zeros from the related column. Vice versa, if you are assigning 0 of column, cross off 0 in row, related row if any. So now as per hierarchy, this first is over, second is, there is no 0 now, it is cross off. Again hierarchy is for row it is top to bottom, and for column it is left to right. This is the hierarchy to be followed. We have to remember this. Now again in third row there are 2 zeros. So we will go for zeros with single rows with single 0. So we will not do any mathematical treatment or any assignment in this particular row. We will shift over to next row. This row is also having 2 zeros. So now here I don't have any row with single 0. So next chance is for column. Identify columns with single 0. So in first column, see, important step, I have not disturbed this third row and fourth row since there were 2 zeros. What the hierarchy says? You have to assign only to the rows with single 0. And therefore now switching over to column, I will assign in a column with single 0. So that is column A. This 0 I will assign. See now, right now man number 4 is assigned job A. Is it possible that same man number 4 will be assigned to any other job? There is 0. So therefore, as said, when you assign any column, 0 of any column, cross off 0 of related row. For this assigned column, this is related row. So moving to next column in the fashion left to right. This is left. Moving to right, column B comes in order. In column B, identify whether there is only one zero. Yes, there is only one zero. So assign this 0 like this cell and cross off zeros of limited column, related column. Very important step of assignment model. Very important step. Now what you have to do? Check. After this you have to check, is there any zero still remaining? Is there any zero still remaining in this assigned matrix, either uncut or non-assigned? So we got zeros either assigned or either cut. There is no zero which is not assigned. So once you do this step, now we have to apply the logic of step number 5. We have to draw minimum number of lines covering. Now I know, as an engineer, as a OR expert, I know this is not optimal assignment, because for 4x4 matrix I need to have 4 assignment. For 3x3 matrix I need to have 3 assignment. For 7x7 matrix I need to have 7 assignments. In short, in general, for n/n matrix I need to have n assignment. Here for 4x4 matrix I am having only 3 assignment. This is not optimal solution, that I know. But mere saying this is not optimal solution will not do. What is the condition that we have seen in our previous slide with blue line? Minimum number of lines, and the word, very important word in that is minimum number of lines covering all zeros. If it is equal to size of matrix, then this solution is optimal. Now suppose I arbitrarily draw the number of lines covering all zeros, like 1, 2, 3, 4. So 4 number of lines, and you can say that solution is optimal because size of matrix is 4. Not done. One may say, sir, okay, I will draw horizontal lines covering all zeros. 1, 2, 3, 4. 4 number of lines covering all zeros. But students, what is the point of interest is, number of lines should be minimum. I am again stressing word, minimum number of lines covering all zeros. If that is equal to size of matrix, solution is optimal. This is very, very important step. Minimum number of lines covering all zeros. Now we will see the steps for drawing minimum number of lines. We will see the steps for drawing minimum number of lines. So what are the steps? As mentioned in step number 5, various sub steps that we will implement here now for finding further or for optimizing this problem ahead. So the step says tick mark the row which is not assigned. So row 1 is assigned, row 2 is not assigned, row 3 is assigned, row 4 is assigned. So tick mark the row which is not assigned. I have tick mark. This is the step. Tick mark the row which is not assigned. Then what is the next step? Tick mark column having assignments in mark row. So this is the mark row. Here you are having zeros. For this column you are having assignment. It looks like this. It goes like this. Then what is the next step? First is tick mark row which is not assigned. Then mark tick mark column having 0 in tick mark column having 0 in mark row. This is mark row, tick mark row. In tick mark row, this is 0. Corresponding column is this. Second step. First step, again I will repeat. I have tick mark row which is not assigned. Then I have tick mark column having 0 in tick mark row. Then now again tick mark that row having assignment in tick mark column. Very important. Very important. Again I will repeat. First step, what I did, I have tick mark this row because there was no assignment. Then I have tick mark this particular column. Then I have tick mark this column because of this 0 in this mark row. And then I have tick mark this row because this tick mark column is having assignment in this row. Once you do this, what you have to do? Very important again. Very important. Draw lines through tick mark column. Draw lines through tick mark column and untick rows. Draw lines through tick mark columns and untick rows. Students, see that is there any 0? See that is there any 0 which is not covered by these 3 lines drawn by black color? All zeros are covered by these lines. And how many lines are there? 3 lines. Here you can see these are only 3 lines. These are only 3 lines which cover all zeros, which is less than 4, that is size of matrix 4 by 4, and therefore this is not optimal solution. Therefore this is not optimal solution. This solution is not optimal solution. Means improvement is possible. How to proceed? How to go ahead? Let us see. Again what I will do, I will draw 4 by 4 matrix. I will draw 4 by 4 matrix. This is 4 by 4 matrix. We know these are the jobs. These are jobs A, B, C, D. Man 1, 2, 3, 4. Now, how to proceed further? Very important. From this matrix, very important step, from this matrix where you have concluded that after drawing minimum number of lines the current solution is not optimal, that you have concluded. In that matrix, identify, these are the steps we are finding for minimization type of objective function. We are finding for minimization type of objective function. Identify minimum values through which line does not pass. See, through row number 3, row number 4 line passes, no question, to find minimum value. Through column C, again line passes. So you are left with this and this. 6 values you are left with. Out of these 6 values, they are very, very important. Out of these 6 values, find the minimum value. So naturally this one is minimum value. I am marking with double line. This one or this one is a minimum value through which line does not pass in previous solution. What we have to do? We have to create more zeros for further iteration. Why this step is implemented here? For creation of more zeros. So now what we will do? We will subtract this minimum value from the same value. So same number minus same number will yield 0. In that way 0 will be created. So this is very important step. So what you have to do? You have to subtract this minimum value from the values through which line does not pass. First step, add this minimum value to the cell through which 2 line passes, means there is intersection. So intersection is at this point and at this point. So what we will do? We will add this one to this one, we will add this one to this 2. Step number 2. First is subtract, second is add it to the squares where 2 line passes, and third, keep other values same, other values of the cell same through which line passes only once. Means, in a simple way, in the cell where line does not pass, you have to subtract. In the cell where line passes once, you have to keep those values as it is, and in the cell where line passes twice, you have to add that minimum value. So now we will execute that over here. Line does not passes, so 3 minus 1 is 2, so new value I got is 2. 1 minus 1 is 0. First we will write subtraction, then 5 minus 1 is 4, 7 minus 1 is 6, 3 minus 1 is 2, 1 minus 1 is 0. This is first step I have done. Now this is the intersection where 2 line passes. So this 1 plus this 1 is here at this point, it is 2, and here it is 2 plus 1, 3. Now to differentiate, what I will do, for understanding purpose, I will write it by other ink to highlight, and keep other values same because line passes once. So this is 0, this is 0, this 0 is as it is, this 0 is as it is, this 3 will be as it is, 4 will be as it is, 2 will be as it is, 0 will be as it is. Students, being first problem, what I did is I have used different colors for your understanding that how different values are obtained. So red colors values are obtained by subtracting minimum value. These pink color values are obtained by adding that minimum value since it was intersection, and remaining values with blue color are the values to be kept same, because line passes once. So we are now ready with improved assignment matrix, and we are ready for assignment. And now here in this matrix we will carry out assignment. See how we go. We have to follow this rule. If you don't follow this rule, definitely you are going to commit mistake. What the rule says? I am again and again repeating the same thing. Rule says, go from rows top to bottom, go for rows top to bottom with single pure independent zero. If these are exhausted, go for column second priority, third priority row with double zero, fourth priority column with double zero, fifth and sixth priority. Now see, in this first row we are having two zeros. What we need? 1 0. So we will not disturb this first row. We will switch over to second row top to bottom. Again 2 zeros. We will not disturb it. Third row. In third row, yes, there is single zero. So what we will do? We will follow this rule and we will assign. We will assign like this and cross off zeros of related column. Cross off zeros of related column. This is done. Now what we will do? We will go for yes, here something is here. We have committed one mistake. 4 3, it should be 2 0. Three, 4, 2. It is 2 and it is 0. So the values where this part is representing man. So 3 5, so 3 become 2, 5 become 4, 2 as it is and 0 as it is. Rest is 0 6 and this is this will be again 0 6 0 and 2. So here 0 6 0 and 2. So let us go back. This has created a mistake. A3 A2 4 2 0. B column is 1 minus 1 0, 7 minus 1 6. This is 0. This is 2 done. 0, then 0, 1 1 2 2 3. Then this is 2. This will be 0. Then here 0 will be as it is, and this 0 will be as it is. 3 zeros. And now we will go for assignment as per our routine practice. So 2 zeros, 2 zeros, 2 zeros, 2 zeros. All columns, all rows are having 2 zeros, no single zero. Now we'll switch over from this concept to column with single zero. So this is the column with single zero. So I will mark this particular column, this particular zero of first A column, A job column, and cross of zero of related row. This is first assignment. Now search for column with single zero. 2 zeros, 2 zeros, 2 zeros. So here students, this condition of single pure independent zero in each row and column is exhausted. Now we have to switch over to second category of assignment with double zeros for first 4 rows and then for column. Very important point here. You have to be alert in such a way that while carrying out assignments, see that you are preventing zeros from cutting, because in this exercise what we did, we have created zeros. While assignment, be alert that you won't do assignment in such a way that zeros will be cut. You have to prevent zeros from cutting. So now if I do assignment over here, I will cut this as well as this. If I do assignment over here, corresponding zero will be cut, corresponding zero of column will be cut. Now here, this is a very important step and very important problem. If by mistake, what I have stressed in my deliberation, you have to apply your mind in such a way that you should prevent zero from cutting. If by mistake if you assign in this particular cell, you have to cross this zero as well as this zero. And if you do this business, you won't have assignment for this man 3, and the problem will go in loop, in a dangling way. You will not move towards optimal solution. So what care you have to take while assigning, prevent zeros from cutting. So we have to assign this particular zero, cross off this zero, and now only 1 zero is remaining. So this is the last zero assigned. Now check, is there any zero which is assigned? Is there any zero which is left to be assigned? First row is having assignment, second row is having assignment, third row is having 1 assignment, fourth row is having 1 assignment. So after carrying our assignment in this logical way, we could get this final assignment. Students, there is no need now to draw minimum number of lines and all that, because the problem is, algorithm of this problem has terminated. Every row and column has got 1 assignment, and it is assignment problem where each row and column will have 1-to-1 assignment. The problem is over here. How to proceed further? How to interpret the result rather? See here, I will rub all these things. I will rub these things because we need this space now. If I switch to next slide, this will be erased. So now, how to interpret? Hence assignment is as your combination was man with jobs. Your combination was man with jobs. So how to write? That is very important. Man 1 with job B. Man 2 job C. Man 3 job D. And man 4 job A. This is the assignment, correct assignment. Now we will see. And total minimum man hours is equal to. How to interpret this result? See, this is the square cell where you got assignment 1B. Go to original matrix. This is your original matrix. This is your original matrix. Go to original matrix. Check the value 3 plus 2C 2 plus 2D 3D 7 plus 4A 5. What I did, since these were the assignments, I pick up values in the units of hours from original matrix. Sum it. 3 plus 2 5 plus 7 12 plus 5 17. So answer is 17 hours. Answer is 17 hours. So this is exhaustive treatment. This is exhaustive treatment for solving any assignment problem. Here it was with objective function minimization. So the various steps which we have performed in this particular problem, first we have checked whether it is square matrix. Then we perform row operation, we perform column operation, then we carried out first assignment that was not optimal, then we draw minimum number of lines covering all zeros, then amongst that we have selected minimum value through which line does not pass, we have added that minimum value through which line passes twice, we have subtracted that minimum value through cell values through which line does not pass, and we keep other values as it is, and after that we have carried out final assignment. And for this 4x4 matrix we got one assignment in each row and each column. After getting this assignment, you have to interpret your answer, final answer, in this form: combination of different man with jobs, these assignments from this matrix and their timing from original matrix. Minimum man hours was the data given. So these three comes as a result of assignment of man 1 with job B, and the value is 3. This 2 comes from this cell 2C value is 2. This 7 comes from cell 3D, and 5 comes from the cell first cell. Addition of all those will yield your final answer. This is how complete assignment problem is solved. Now let's move to other problem. Got it? Here you have to try multiple problems. Once you understand the steps, implement those steps, and your mastery will be only if you solve number of problems. Now, switch over to further problem. See this problem. In this problem, four different jobs can be done. Again, the machines, in earlier problem it was the job. Now in this problem it is the jobs to be allocated to machines. Jobs are labeled as J1, J2, J3, J4. Machines are labeled as M1, M2, M3, M4. And the matrix gives cost in rupees. The matrix gives cost in rupees of producing job I on machine J. See here, the meaning of this is, suppose you allocate, you think of assigning job J2 to M1, it will cost 8 rupees. Like that, J3 with M3 will cost 10 rupees. That is the meaning. What is asked in this problem? How should the jobs to be assigned to various machines so that total cost is minimized? So objective function is very clear. Also formulate the mathematical model. This is additional part that same can be formulated in the form of linear program. Right now we are interested in finding solution to this particular assignment problem, where cost of assigning these jobs to the machines is to be minimized. That is our challenge. So this is the table after you perform a row operation. I will explain with one value. For this first row, minimum is 5. So 5 is subtracted from all values. 5 minus 5 0, 7 minus 5 2, like that. Now this particular step here, you can see this, after performing row operation, this third column is not having 0, so you need to perform here column operation. You need to perform here column operation. So keeping these values same, 0 3 0 7 same, 2 0 3 1 same, 1 1 3 0 same. Perform column operation for this. Minimum is 4. Subtract 4 from all these values. 6 minus 4 2, 4 minus 4 0, 6 minus 4 2, 5 minus 4 1. Now you have to assign in this particular matrix. We have seen exhaustive variety. So carry out assignment. How that is done, I will explain. Now here you have to start from first row in the hierarchy of 0. You have to assign this particular cell. That we will see now how to proceed. I have solved this complete problem. See here, first this 0, then in the same order last. If you assign all zeros by our step number 4 method, prior to that row assignment and column assignment, column operations are over. Now you are ready with first row having assignment, second row having assignment, fourth row having assignment, no assignment in row number 3. So step number 5, recall step 5. Step number 5, what it says? Tick mark this particular row. So see, this is the tick mark row. I am again doing for this. This is already solved by me. So tick mark this particular cell. These steps were thoroughly explained in our previous problem. Now once you tick mark, then identify where there is 0 in tick mark. So this is 0. So tick mark second. This is first step. This is first step. This is second step. Now what you have to do? In this tick mark cell, identify where is the assignment. So here the assignment is in this cell. So under third sub-step, this is third. And what you have to do? We have to draw lines through unticked rows. These are the ticked rows. These are unticked rows. This is also unticked rows. And through tick column. See here, minimum number of lines are 3. So 1, 2, 3. Minimum number of lines 3, which is less than 4. 4 is size of matrix. Means improvement is possible. And what is the step in that? You have to identify minimum from this. You have to identify minimum from this. And if you identify minimum from this, means which value? 2, 2, 1, 3, 2, 1. So minimum is 1. So what is the next operation? 2 minus in next table, which I will draw and we'll see whether it is the same. In next table, what we will get? Again, this is for your understanding. This we have done in detail in previous step. 2 minus 1, here it is 1, here it is 1, it is 0. 3 minus 1, here it will be 2, here it will be 1, and here it will be 3. See, line crosses twice in this cell, value is 3, minimum is 1, so 3 will become 4, this 7 will become 8, and rest of the values will be same. This 0 will be as it is, this 3 has become 4, this 0 will be as it is, this 1 will be as it is, this 1 will be as it is, this 0 will be as it is, then this 0 will be as it is, this is as it is, and 1 will be as it is. So this is the matrix which we get in for our next iteration. And in that we have to apply logically again the rule that go for row with single column. So if you do that, what will be your, in first it is 2, in second it is 2, in third it is single pure independent 0. If we go by that logic, if you assign over here, this will be cut. If you assign this will be cut. Again, this is the row with single 0. If you assign this will be cut. Now it is very clear that since these two rows have cut, the zeros have cut from the first row, means as a OR specialist or OR consultant, we should get idea that now since there is no scope in first row, after applying we will be again going for next improved solution. So now right now what we will do, we will stop here for today's lecture. From next lecture we will go onwards from this topic, and we'll see again more varieties of assignment problem. Right now we have seen balanced assignment problem. In next lecture we will also see unbalanced, means m by n matrix problem, and where we will be balancing first the size of matrix and we will go for solving the problem by applying Hungarian method. So right now, till then, try more number of problems in the similar fashion. We have seen the methodology for assignment minimization problem, that we will be continuing. So till next lecture, practice all these things.